Welcome everyone to another live stream implementing this quite okay image format as just shouted out on the main channel. I could reuse those other libraries, and for other stuff like libpng and stuff we do. Also here just need to orientate myself so that is there. Just build ExactImage because of course I did need to check the how do we okay, that was not something like that, I guess. So implementing the stuff, I think this, oops, we have an UK layout from yesterday because pipe symbol and stuff. Actually, we probably need to use ExactImage. So yeah, welcome to some live C++ code, of which we might or might not see more for microkernel stuff. Let's start with adding a new image codec. So this is in C, ExactImage is here. So probably, you know what did we, should we, with which do we start? Maybe should we copy my proprietary, I didn't check this out, okay, then not. Did we commit JPEG? Also it's not an image, this is a codecs. Do we have JPEG XL here? Yes, we have. Let's copy that. I think this was relatively simple. So that would be quite, what was it? The abbreviation was QOI, H. And CC, of course, we will rewrite that mostly, of course. And also we need to stop this live preview here. So yeah, this is on an Apple Silicon. I added this to the title. Yeah, so welcome on Apple Silicon M1 Max, QEMU, T2 Linux, obviously. So ExactImage. I also this year, so New Year's resolution. I've not abandoned my New Year's resolution yet. So we will have more microkernel stuff, or in general more new stuff. I'm just thinking which language we will really use. So eventually probably also a new text editor, because this ExactImage is aging a little bit and bit rotting and will update in 15 years or so. So I need a new text editor too. So probably want to share, like, and subscribe for crazy YouTuber also writing text editor, because there are not hundreds or thousands enough of those. So codec, QOI, both of those. And then let's hack away. So the header will be relatively empty. This will be just, so how do we position this? This also, all right, this is a little bit usability problem of, no, I did not think that through very well. Okay, anyway, we can work with a lot of stuff. Let's make this fairly new. Not that it would matter too much, but whatever. Then a new image codec. Class quite, I think I always forget this, quite QOI. Maybe I should actually substitute that there. So that registers this codec for quite, I think it's, let's double check that. This is also Alt Tab going to macOS. So I downloaded the examples already. They are in, what was QOI, hello? It's there. So I had run that already. Maybe in another terminal, ExactImage QOI. So this will of course not work. The result, they have PNG, so this is how it should look soon. Just for the QOI, yeah, QOI they use there. QOI for the codec name, this is just the codec name QOI. So then read writes, okay, this is all we need here. I just can't see. So the problem is I can't resize this much. Okay, fine, doesn't matter too much. Let's get. So Then this will be new today. So then all this XJXL stuff, of course not. Then include our new QOI header to do everything, obviously. And then JPEG XL to QOI, and instantiate that QOI. And then so this is compression. We will implement this later. Let's first implement loading. Let's maybe not delete everything. Maybe it is smarter to, by the way, smarter would also to present it so that you can read it. Nothing like also wasn't that bad. Just should, yeah, QM mouse handling. Yeah, I wish I could. I can move it. How's this? Because lucky. So that's better, isn't it? Amazing stuff. So, actually, maybe. Yeah, also 2022, getting comfortable with your own Linux or Mac OS, right? Because ARM64 silicon. So then, quick magic check. So this stuff, where do we have that? Buffer 4. Okay, we have buffer 4. Seek read size buffer. I can even use that. And then this should be actually so ideally I would code this differently. Just today we quickly do not best practice QOIF. So ideally I would want to write this equals QOIF, but this is not zero terminated and stuff. So let's let's do it quick and dirty. Does this even work? Oh, this worked. At least something. All right, but no, we can't. Yeah. The fun of QEMU. Yeah, so I wonder why those folks didn't get the keyboard mapping stuff working better on default, but maybe previously not too many people were using QEMU on macOS Q, or again, not my preferred style. I need to look on some really nice code to do that later. So right, so let's also open, I think in the BMP codec I have some nice endianness stuff, reuse here. Oops. And because we want to reuse our endianness handling, because this stuff is big endian, which is kind of, in my opinion, the right endianness. Also network endianness, right? So the problem is we can't copy that anyway, because virtual machine. Maybe I should actually look up some proper hex configuration hex for QEMU for macOS. So with the naming QOI header, so the problem is, like, for 20 years I didn't quite form an opinion what is the best naming still. Not that one character would matter so much. I need to do some guru meditation before I start writing more microkernel or other low-level graphic driver stuff, to form a better opinion what I actually want to use for that. So that would be character magic for yeah, nothing like using US keyboard live on YouTube. So and you know, so what we probably want to do soon is define some nice helpers. The last time I so we want unsigned. So basically what I want to do this time, oops. Oh. Type def that to, do I even want to do it like that actually? So actually, wait a second, they are, we have big endian here, so big endian is traits. So U32. So we could like little endian, big endian. Should we like maybe big endian with that? Actually, oops. Using that. So and then let's. Do they call this magic? Okay, they call this magic. So U32BE with height, channels and color space with height, channels, color space with height, channels, color space. And what we could do, we could not, to simplify the string comparison, this is of course also basically integer 32. We could treat this like this, what is there, for, what is it, the C code, there's this, 4cc here. It's so simple, right? So simple yet so. So basically, we could treat this theoretically, this magic, like not how they type it out, but as a 4cc thing, and then also have this comparison easier. So we have a couple of more things. Actually, maybe I should open that in. It doesn't matter too much. Otherwise, I could open that in Firefox locally and yeah. So read. We could also actually reuse that here, right? If we already specify, what makes this stuff a little bit more complicated. Yeah, it doesn't matter too much. So let's delete more JPEG XL stuff. Then read file. Why did I had here? Oh, this is the size. Okay, this was super. Is it beginning? Is it that? So this is really stupid code here from JPEG XL, because what we want is a QOI header and read that. So the seek we only need because we had already 4 red. We could also, we could actually simplify that and say, okay, we like basically later changes a little bit. And welcome everyone. Later changes a little bit, not seek and simply reads the header because we don't need the rest of that. Just for now. So that would be header. And here's this decode stuff. So basically this is what we need to set in our own image format. Bits are currently always 8. We can hardcode that for now. Samples is actually header, channels, format data type, resize, header with header height. Welcome everyone. Notice define channels. All right. Thanks for that. Always helpful. I simply quickly define over that. So we probably make a define for that too, so that we can use U8. I think for my future work, so previously the last 20 years, or the last 15, 16 years, I used the UN bits underscore t. I think there are two problems with it. The first problem with those defines, with these int types defines, are that they do not encode the endiness, and then if you use them all over, they are a little bit verbose. I mean, otherwise, this int types, amazing stuff, which, yeah, amazing stuff of integer defines. But I think for my future work, I use it like that. Then we have also the benefit of being able to use additional C++ template magic. And basically, do we need any other stuff? Maybe we probably need UN16 also, I guess, and then otherwise type def. This is basically similar to the Linux kernel header type, Linux kernel type. They also use, I think they use U8 and stuff. The only thing is due to the Linux kernel previous video with probably I made a video like 1 or 2 years ago with a SunSpark fiber channel. There they also swapped the endiness, right, with their cleanups. And so because Linux kernel is C, they can't use this fancy 20-year-old C++ generic programming tricks like automatic endiness conversion. And yes, this endiness conversion stuff, this endiness converting stuff is nearly 20 years old of ours. And in the future, I would use something similar. What language precisely we will use, we will see, but I need to abbreviate this a little bit. And in 20 years later, I don't like this very verbose names anymore. Somehow there needs to be some middle ground between too short and too long. But so type def uint8 t8. That of course does not have any endiness. That probably should work. And thanks for that. So, what else do we have there? Something. Bits per second, samples per pixel. So we need BPS, SPP. So, and then basically, so what we should check is whether this is a supported format. Need to get a little bit familiar with which control keys work here with QEMon. That comes from using this foreign software. We also should actually have here some packed attribute, because otherwise, due to the nature of the C++ structs of wrapping the endiness stuff, this might otherwise not be packed. Packed meaning this stuff being, although in this case probably not, but otherwise this stuff might also, depending on the architecture, be otherwise more naturally aligned. So we want this freaking packed. Basically, we could already try if that works so far. I like to actually continuously test stuff. So we want to read that. So we need to do some error handling on the C++ streams, are not the greatest for error handling. And so the magic we checked, we should check channels, is if header channels less than. So currently they only, this is Garn, this is this stupid shit where I can't, this is so hilarious. This bloody, oh wait a second, can I type it here? No, I can't. Yeah, macOS QML. Brave New World can't even type a freaking lesson. Wait a second, where is it even? Yeah, that is such a time wasting. I mean, yeah, state of IT, right? You can't even reliably type. This is so hilarious. Where is it on a UK keyboard, on a US? Oh, wait a second. They are here. I can type it. It's not there it is. Just need to know where it is on the US layout. Also, yeah, part of the IT stuff is of course sucks so much because everyone is using US stuff and international stuff is like, yeah, YOLO, whatever. Less than 3 or more than 4. I mean, we could verbose print out while we implement this that we know where it is failing. But yeah, just freaking use a US keyword and you have less problems. Return false, and let's, oops. Do the same for, what was it, Colorspace, so that is, and so if that is, this we can simply check. Greater 1. I proposed already, I opened a GitHub issue at them, Colorspace, to support gray. I hope they accept that. I propose there to use channels equals 1 and 2 for gray and gray with alpha. Maybe let's see if they like it or not. That would be cool. Maybe I implement this already as an unsupported like experimental extension, because why not? So let's compile that. Some stuff has not been defined. Forbids QOI codec, so that is in QOI header. QOI. Also typo. Nothing like a good typo in your class name. That already partially worked there. Ignore the JPEG. Recurrent amazement of upstream stuff. So let's run this directly. So this will of course currently display random stuff because we're not loading it fully at all. So this is just trying to read the header. So QOI, unsupported channels. Okay, would probably be good to log that. So we have there width, height. Actually, yeah, we have that packed. Is there anything with height channels, Colorspace? With channels, Colorspace. So we could attach GDB, header, read size of header. What did it say? I type nothing like having 2 OSs. Supported channels. Maybe we should less than 3 or didn't save that because US layout. Channels is this is also one feature I don't like the most. This uint stuff. That is the nature of having like 8-bit integers mapped to characters, and then printing this out as a characters, like ExactImage. I probably edit the config and disable Swig, to be honest, just to save a lot of recurring build time. What did I say? Swig. Don't need to rebuild this bindings here all over. Channel 0. So we have here QOIF 001 what 0. So yeah, so this is 256, 256. We have here 400. What have we done there? Hello, where's my... Where does my alt top down? Hello, no, maybe. What we probably should do in the future, but in general, this language, yeah, maybe I should take a closer look at Rust, so for memory, safer memory stuff. With channels, Colorspace. The question is, of course, did we build with debug symbols, GDB? No, we did not. Let's see. GDB, object display, QOI. Oh, wait a second, this doesn't work. Test QOI, break, QOI, codec. Okay, the width is already strange. Oh, wait a second, did we? Oh no, this size. Can we? P size of header is 10. Yeah, and this is, by the way, why it is, of course, more clever. Somehow my tab key, maybe my Junior pressed too much randomly on the keyboard. I have the feeling the tab key doesn't work the most amazing anymore. So 10, we have here 4, 4. It actually looks correct. What do we do there? Actually, it's maybe... So 10 is, so we have 4, 8, so 10 is correct. Why does this not work? We read 4, we pre-read 4. I mean, what we could do is define this header earlier, but that's not our problem right now. Header, size of header, slightly wonder what is going on here. Wait a second, this is why we seek here to that is why. Always the most obvious, copying old code and then wondering that. Yeah, sometimes basing on some other old code can also have a bug. Did we not save that maybe? No road file. Buffer, read. Actually, let's do this more modern. I don't like a space there, not that it would matter too much. Why does this still not work? Oh, wait a second. Why do we didn't even compile this in? Yeah, because we didn't update that. So yeah, those who can read are obviously, as per usual, at an advantage. Obviously not us. Do we return true? Why does this error loading file, why does it error? I would have expected... wait, why do we... just looking at that and then still. So, okay, this is already the right size, so now we can start decompression. So basically, while we can read stuff, so now comes the actual decompression job. So, so this works with, alright, I also want a zero initialized array. So how do we do this? The most intelligent, probably. Yeah, probably I should actually start in Firefox here. Also, can I maybe wait a second? Do we have control? Okay, maybe, should this work? Maybe it should work. Let's also hope that works. Not sure does it even work, because as usual, those who program all day on Linux distribution, they usually have the least working Firefox setup, whatever. Because then we can actually potentially, hopefully, copy and paste some stuff like this index. Let's hope that works. It doesn't. At least not that. Does that work? Yeah. 2021, copy and paste between programs. All right, maybe actually Firefox doesn't support this. That works. So let's type out the other stuff. Maybe from here. So we have op RGB. How do we do that? Most clever. Could actually check their reference code QOI for inspiration. So how do they do this? Here's all the file format stuff in there again. So we sometimes have an 8-bit tag. They also have the header without the magic without they have your QOI description. So the C stuff of theirs is not directly matching the names in the standard. And that is their open-coded endianness swapping stuff, exactly what I want to avoid. Also, you're not the greatest fan of this unsigned int stuff because this size might vary, right? So best practice actually, the recurring live code review use like bit size typed ints, so like int, if you want, yeah, uint32 or something. So where do they check? Do they have the other operators encoded here somewhere? Here they have a union of RGBA or RNV. Okay, this is their. This is probably their cache thing. Yeah, header size. This kind of stuff I would usually use size of the header, but yeah. Okay, not the very biggest. Let's see, inspiration. They have those bits, so we have some. Maybe we should. Can we make this? Why does this not zoom? All right, because it's an US keyboard. Where was the plus? So we have RGB. So maybe each chunk starts with a 2 or 8-bit tag followed by a number of data bits. So probably we should probably read the one page in full. The bit length of chunks is divisible by 8, so all chunks are byte aligned. So we probably should always read 8 bits. 8-bit tags have precedence over 2-bit tags. Decoder must check 8-bit tags first. So possible chunks are, so we need, so tags, let's see. Still, yeah, I need to somehow prototype a little bit with naming convention still. So we have ops, QOI, op RGB. RGBA. I think I didn't copy that. Yeah, QEMO doesn't somehow not automatically map that. Scrolling to directions, so Q op index 0, 0. Oh, wait a second, we also need to prefix this with a 0. We somehow probably need to open code some, well, there are various methods, of course, but I think we open code comparing the full 8-bit as they suggest. They're decoding that first, and then if not 8-bit tag, then ending that to 2 bits for this op diff. That is tag 0 B1. What else do we have there? Op luma. Op diff. Diff green. Something different. Previous op. And And last but not least, op run 1, 1. Then we need this other fields. So actually quite some people watching, which is interesting. How do we specify the other stuff? We could specify them as bit fields. So basically, let's maybe make notes what the other fields were. So this is just bytes. Okay, this was channels present from what I saw on the blog post. So these are just the values. Should we? Does it make sense? Okay, let's later see if it makes sense. So index we have. Maybe where do we? Let's maybe document it here for now. That is 64 possible value index. How do we? U8, not really, but something. Op diff is also U and 8. Basically dr. I mean, we could specify those as a union. Not sure if it's the most. Basically, this is drdgdb. What was the other? That was index. Diff, and then diff loomer is, how many bits are that? Okay, these are 6 bits there and 4 bits there. That is loomer U16 basically. DG RG, what is it? Was it RGB? RGB, and this is DG DRDB. And then what else do we have? Run op run is, that was U8, right? I mean, we could do, yeah, probably start reading that and implement those occurrences where we go. Did I? So this has a bias of 1, so 0 means 1, it's 1 to 62. What was the end of stream marker? The end of stream marker was 8 bytes, end marker of array, something. The color channel are assumed not to be pre-multiplied with the alpha channel and pre-multiplied alpha. 0 initialized previously seen pixels. So we need some kind of pixels, so maybe QOI pixel. RGBA. And basically we only need it from here. QOI pixel. How do we call this, history, or how do they call it? Running array of, I guess we could just call it history. How do they call it? Just call it index, RGBA T. So they have a struct, okay, they have RGBA and value. Do we need that? It's interesting, but not really probably necessary to do it like that. Anyway, I think we don't call it, so they call it index. I think history is more verbose, more readable, more understandable, hopefully. 8-bit text, so where is the end thing? Where did they document this? There was like followed by 7 times. Marked with followed by byte stream end is marked with 7 0 bytes followed by a single. Maybe we want to check that eventually. Not really sure why we need that, but whatever. So let's maybe see if it still compiles. That's the builds, all our typed, all our, at least some stacks. So we have some people watching. The question is, how long do we live stream? 50 minutes, it's not too bad. Should we try to get this working in one live stream? Yeah, basically this is how I tackle stuff, usually bottom up. I would call that. So we have at this point an RGB or RGBA. We need some, so basically how do we do this best? We need some kind of image iterator. Should we, what was the name of, because we have an old and a new one. We need a way to set that. Okay, let's maybe first read this. Did I had? So basically, while we could try one test pass. And how do they? Actually, they do the magic check. I just saw they shifted the ASCII values together. Similar to my 4cc thing I mentioned. Okay, so they have here the bit defines. I find my byte patterns from this a little bit more readable when you are, well, although you maybe can't rely on your C compiler being new enough to support byte literals, but yeah. Color hash, so we have, here's the color hash. Do they have differences? Read 32, encode. QOI decode, how do they do it? So they read the magic, hide stuff, and then they read here QOI padding. Okay, plus channel. So they iterate straight over the bytes. Copy that over for RGB. Open coded. Okay, they have here a pixel value. So they assign their pixel value from the red bytes, otherwise from the index. Otherwise, the difference they compute. Okay, they have a last pixel. Okay, so they reuse that in their loop and directly assign that. Here is the difference in the loomer. And then they always store that, updating the history. Yeah. This is what I always, naming. How could they name this index? Yeah, I mean, index is still fair, but anyway. Okay, and then depending on whether it's 4 channel, they either store the whole one or only, so either the whole 32-bit at a time or the AGBA differently. I think the performance would be way higher if they would not compare the channels here in each iteration. So, what does it mean for us? For us, okay, so this means they don't have a struct for that. Actually, I wanted to look up if they use some fancy byte structure for that. So how do they even... Okay, they supply here all... Actually, what is their API? Apparently, okay, they can only decode the whole read. I mean, so I see here multiple... I mean, besides this being C and stuff and recurring theme buffer overruns, yes, we only use C++ and need to be careful not to implement the same security issues. But so there, when you wonder why do you not simply use their stuff, I want to get to some more modern implementation, like basically everything without C in my microkernel and stuff, in my hypothetical whole system. Yes, C++ not ideal. Maybe we use SIG, maybe we use Rust, we will see. Maybe we implement something in between, because somehow Rust is also too complex for me. I don't really want to base my future on something as complex as Rust. But so multiple things to optimize the performance. If you wouldn't check that here on the channel on each pixel, we could in C++ use our pixel iterator code generation that we have in ExactImage and instantiate this code multiple times so that the C++ compiler should hopefully create quite ideal code for each pixel type. And the second is, this is also clobbering the caches, the CPU caches unnecessarily, because they can only decode whole data at a time. So with some more streaming decompression, without basically without reading like reading a 4 megabyte image already, yeah, clobbers all your caches and basically with a fancy like carefully implemented streaming. I'm not saying that our quick and dirty C++ code will do this in the beginning, but if you more carefully structure your code for streaming the data in smaller chunks without, yeah, I mean, if you load icons, then it doesn't matter, but if you load larger images, then, or even think embedded, right? If you do this in a microprocessor, microcontroller with very little memory, then you also potentially don't want to load all of this. Wait a second, what kind of if style is this? Who is coding like that? Oh man, really not a fan of this style. Wait, here they use that and here they use that. Why? Yeah, code review. The code review channel. So yeah, basically we need to continue implementing that. Then, so histogram does this struct. Let me check. Does C++ support explicitly? Wait a second. Should it work like that? Did this compile? This is compiled. So this should zero initialize that, hopefully. And then while or we could call this tag. Actually, what we also need a pixel, so maybe should we? Because we need a previous. Oh, wait a second, we have a pixel defined already. Histogram and so the only problem with that is that this might, yeah, so some like 20-year-old APIs are really not cool. Oh, wait a second, this is actually, you know what, we could we optimize it? What was the, actually we should not start optimizing that already, but we need it. Oh no, we might only need one. Yeah, but yeah, there is a huge optimization potential, including processing multiple runs at a time or something, and reading like always a minimum of like 32 bytes or something. But let's not get ahead of ourselves. So I wonder, leave in the comments below. Welcome everyone. Should I continue here? Can we implement this in 2 hours? 1 hour gone. What is the most I'm getting. Do they have here? So what do we have for read? Do we have a single int for read 1? Like get? Oh no, freaking close. Extract single character from the stream. So yes, this is also not high performance, but let's keep this simple. The only problem is we can't use, so this is int, so tag, so this is probably, so this is not yet high performance, at least it's streaming, but it also has some other benefits, right? Theoretically, you could implement an HTTP access streaming that, so and or in memory, right? So it's not ideal performance, speaking about cache and stuff, but at least it's more flexible, right? In contrast to C files, you can string stream or HTTP stream and so on and so forth. Yeah. Stream, get, and then tag not equal end of file, that is EOF of, what was it, std, EOF, but no, this is, I think it's -1 usually, but return end of file value EOF, so this is std, generally -1, yeah, so that should be check into file indicator FEOF. No, I don't want, I want simply, where's the EOF thing? Nah. Where was this bloody EOF? But this is not capital, is it? Macro defines character traits in C++. A macro corresponds to the value character traits. Character, not cool. Yeah, you know what? Let's type in -1. Let's fix this later. I can't copy and paste this easily now without. So tag get tag not -1. Theoretically, we will see what else we do with that. So then tag. So we have here which tag. So the problem is I use so many languages. At times, if I work some days on whatever, so is it switch? I think it's switch. Case QOI. Was it even the syntax? Damn, I so start to forget. Can't make this stuff up. Manager tries to write the C code. Yeah, this was what it was. Oops. So case QOI, where's our, we have, did we type this out? Yep, so the, also in our language, the reason why I would consider, yeah, like some, yeah, but anyway, because they are global namespace, not a fan of this enums of, yeah, but, so QOI, let's, you know what, let's copy this also. So, okay, this is a little bit annoying, but that's what it is. Oops, wait a second, this were, so we need to check the 8-bit one first. And so switch in these default and so these we can use. Somehow my keyboard is ruined. Maybe don't let kids play with your keyboard. So those we can use directly, and those we need to switch again. So switch the top two, most 2 bits in tag We could define the mask. We should define the mask. So these are the topmost bits. Did we correctly define those? Oh, wait a second. We didn't. Oh, darn, this sucks. We could, why did we do it like that? So we could 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. We could shift them 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. But maybe that is easier to simply 1, 2, 3, 4, 5, 6, 7, 8. Yeah, leave in the comments below. Always 100 million ways to do stuff. Because then we can simply end that. So what we alternatively could do, but it always depends on assembly micro optimizations. If we could have shifted that down, but we still need that value anyway. So yeah, whatever, however way you do it, doesn't. Such micro optimizations usually don't matter too much. I actually probably would usually go for readability. So readability wise, I would in general, yeah, this also will be the design decision for all microkernel stuff. Readability and simplicity first, and other stuff later. So index, so all of those are slightly different. How many bits did we need for those? So run is directly index 2, so run and index, and the other are 16-bit. Run and index. And those are 16 bits, so actually we can, so what we could either, whatever way you prefer, you could either start running this and see if you can at least decode something and then implement all the pixel delta computation. So basically we could, should this all, I mean, we could try assigning pixels directly. Here we need the other, so basically, you see here already, for example, we could always read 16 bits, for example, as a tiny micro optimization, and have them already here, and then only read, like always read in quantities of 16-bit, for example, or so, something like that. Or even larger quantities, especially as we have a 8-byte end marker. So 3 more, wait a second, 2, no, 3 more, wait, yeah, 3 more, 4 more. Here, nothing more, directly use it. I think from what I've seen, their compression works over scan lines. Some other, maybe PNG or BMP or some other, maybe BMP, restricted that to not run length and code over the end of a scan line, of course wasting a little bit of efficiency. From what I've seen, I think it basically just linearly continues to write data. By the way, given that we always actually have here the right image object, image class, matching channels, we don't need to template instantiate this for all possible bit width here, pixel depth. We would only need to somehow optimize what I said earlier, 3 and 4 bytes. But due to that, we don't need any fancy conversion and can directly assign it similar to how they did it. So this is directly this differences. So this is +1 and here also +1. And so actually we have a second condition here. How do we index into our data? How do we index into our data? Maybe actually we can either int I start with 0 or we definitely also need for security a not advancing over the end of the image data here. Yeah, let's first get it to work and then optimize it further. In general, I need to think about some concepts for the microkernel to have some, depending on what language we use. How do we call that? Maybe we call this IT for iterator. Does it even? I think that compiles. I think we have U and 8T. Does it stream tag at 4, tag not equal 1, and basically did this infinite loop for stuff? Interesting. How does it tag equals get tag not -1? Yeah. Optimized out. No, thank you very much. So much to quickly do something and an amazing infinite loop. Stream get tag not -1. Does this happen to accidentally work? How can that? What? Wait a second. We don't only want to initialize that to tag. We don't even. A little bit miss. So the thing is why I'm. So each time tag equals the next. That probably should work, right? I am actually a fan of keeping all the loop variables in one for expression. Not to have those assigned. It's a little bit unorthodox, although some experts 20 has already recommended similar stuff. At least if you try to stick to this, you have all loop-related control logic in one line. I kind of like that. Okay, so this has a chance to start working. So we have pixel data. At the end of the stuff, we should have pixel data. So if we open code that, not amazingly for now, later to be optimized header channels equals 3, then I mean, theoretically, we can open code assign that to iterator. Actually, basically, I probably don't. Or do we? It's simple and understandable, but so pixel R. Did we call it like that? What was our pixel? I think we called it like that. We can optimize that though. As I said, this is potentially even less ideal than the other example code, but at least it's readable. Oops. Oops, forgot the plus plus. So it's not the super most amazing, but at least it works. RGB. And if we have, yeah, I don't want to have this in production like that, although it works. It's not ideal. We could, however, theoretically support gray data if we wanted to do that like that. So basically, if channels greater 1 or stuff, and optimizes to store 32 at a time, but basically RGB. I wonder how the compiler would optimize it already, but we somehow want to instantiate. So basically later we might want to have this decoding thing as a template and instantiate it twice or each time for each channel. RGBA, that could work. Also this should, I mean, basically we only need to check the iterator at the beginning of the loop and at the run length encoding thing. Given that this only, it's like, yeah, and basically have U8 and equals this const image, actually iterator plus header with header height. And tag not end of file and IT less than end. So here we need to read more. So basically we can read here straight in our pixel. That is unfortunately cast to char because freaking old-fashioned APIs. Char. Pixel. Actually, wait a second. Can we read straight into? We should be able to. This is what endianness did they? No, they defined byte. So this should match our read pixels. 3, 4. That probably should work. Rate was not declared. Oh, also some typo. And RGB and so RGB run. So run simply should run length is stored with bias 1, not the run length of those are illegal because they are op RGB and RGBA. Okay, so run length is, so basically I think we only need to check one extra length in the run length thing, so that would be here. Can we just satisfy, what is it? Whatever, identification-wise. Basically, you only need a new scope here. Not the greatest fan of all this C-based language stuff, but you only need a dedicated scope here if you declare new stuff. So that is, actually we can, you know what, we can actually simply order that away. So basically, tag equals tag and this mask. What? So we probably want a dedicated mask thing. So that is actually this run. Actually, wait, we need the reverse of that. What do I do? Type max. Wait a second, we can shorten that a little. Oops. So, what even type here? And then so run, so simply store the stuff multiple times. Actually, you know what, we could, you know what, let's make this crazy funny. U8 run equals 1. So let's actually reuse the store logic here, and so repeating the previous pixel onto. So let's reuse that and like always have the store logic at the end, and run equals tag here. And so this updates the, wait a second, so this is the thing, previous video I mentioned the operator precedence, a little bit annoying on C. So even I don't know that offhand, so let's better for readability put this into parentheses and wait, and because we didn't declare any new variables, we can actually use it. So so basically what this allows us is to do that here at once, and so for either for so this run length is always more than, actually, you know what, we could do that crazy, aka we could initialize this to 0. This is like crazy micro optimization, so micro optimization mode, and always, because this will always be 0 except updated, and then like for so run equals run plus 1 plus 1, and then run greater 0, run minus run, and Yeah, this still needs more micro optimization because basically we want also to check. By the way, not to check that twice. Actually, we can move that down there if we always check this for storing. And run greater 0 and the rare case of that. Should that work? Run plus 1. We could potentially use negativity. So if we make this signed, actually, we don't have the high bit set, but more micro optimization. Totally not worth it. Micro optimizations. Run plus 1. Run greater 0. IT less than end. Decrement run. Store this pixel. So that probably could be okay-ish. Do we have 8? Let's maybe do this micro optimization already. Signed run 8. Because then we don't need to increment this here each time by 1. Micro optimization for the not run links encoded path. So then reading the stuff. So run links, so that is done. Indexing into the index. So that is actually we need to update. Did we update this pixel already? I think we didn't. Wait a second. This run links is also in the wrong. So the next thing we need is this index. So basically we can compute that from a pixel. Probably making that int q. That is the thing. So should we start this? The question is also, should this be an QOI codec? I'm always with this naming. QOI index of a pixel. So that would be, by the way, do they always have? Yeah, so they probably a multiplied by 11. So if you don't have, if you have an image without alpha, this probably should usually be 0, I guess. Let's try. So that, I mean, I wonder if C++ compiler optimizes this struct to a incertitude. Anyway, questions for another day. QOI index of QOI pixel reference P. I mean, obviously inline. I mean, not that we would need to add that, but return that. And so we probably don't really need to micro optimize that. That is, of course, equivalent to ending that with 1, 2, 3, 4, 5, 6. Not sure if we. So P dot, so we have that as U8, so P dot R, P dot G, P dot B, and P dot A. Welcome everyone. Does look interesting now, considering adding it viewer, so Motor can use it. Sounds amazing. Happy that you learned something new. So, so the index. So basically, we need to update the history with. Should that work? QOI index for the pixel equals the pixel. Does it build? Expected something. Right, the mask. We later changed the code there, so something Q expected. Probably we messed up our inline function here. All right, I here. Oh no, yes, no, maybe. Qualified ID in declaration before. Must be this one, just that I don't. Uh, 150 zero matching. Wait a second. There's also to expected end of output. What did we? Which one? Matching 76. Probably or not. Which? This is why I compile. Yeah. So this. How can this diagnostics be better in 2021, 2022? Qualified ID. What did we last do? I mean, we did this here, so don't see here a instant issue though. I think the issue is further down somehow. We probably here default of year switch. So somehow here we this was it. Yeah, this is kind of stuff. I think in Lua the diagnostics are often even better. Okay, so this still not much visible because we didn't include this indexing stuff. So op index, so that should be index took this directly from the history, I think. Index index, so this is 0, 0, so we can straight, I mean, this kind of stuff we should actually document as a comment. That this index is 0. Could even maybe move this first here and just starting like from 0 to up and pixel from the history. That is tech. Oops, also, yeah, US keyboard. Tech, what do you even type here? Tech, theoretically, we could document that, but basically, I mean, we could actually analyzer compiler. Yeah, I mean, maybe it is better style to document that. I wonder if the compiler is smart enough to figure that. For security, because we index into that, I wonder if Rust could prove that. But yeah. So tag, so run, so index is implemented. QOI out run, so diff. I wonder that nothing is also there. US keyword. Maybe I should look more often what I type. What? Oh, not did save that. I wonder that nothing is visible. I would have expected already some pixel garbage to be visible. Maybe we did some trivially stupid thing. I mean, maybe my code is even smaller than the reference code. Maybe we can also make it more high performance in the next iteration. But first it needs to work. So yeah, this is a bit also. I'm somewhat surprised. Yeah, maybe they mostly use this difference encoding, and that is why that is so empty. Differences, so that is minus stretching differences from the previous pixel, -2 to 1, -2 to 1. Current value of the wrapped operation. So basically, so this was 16. No, 8 bits. So how do we? I mean, theoretically, we could. I mean, we could define a bit field for that, a struct with bit fields, and have the compiler shift and end that. We could. Also, my coffee is empty. Not like having a coffee machine here. We could manually shift that around. So dB, RGB, pixel. Okay, this is not for alpha, so this is pixel R. Plus that, so difference is the tag, and I mean, I don't like open coding that, so probably we will later do it differently. That is 4 down. Maybe first we get it to work and then we make it a little bit more pretty, like maybe trying how bit field works out. RGB, so that would be that and that. And that's not shifted, and that's shifted by 2. It's also crazy that this these binary literals are new in C. Probably they only work like a decade or something, which is a little bit crazy, in my opinion. So we have only for this difference. Do we have only for that 16-bit? Are all others apparently 8-bit? So for that we need a second byte. Basically getting the next. We could potentially avoid checking the error here of end of file, and because it will mean otherwise it would be the very last pixel. Actually no, if we check the assistance of, it's just pure micro optimization, so it's like we could check Let's maybe do it later. Let's ignore that for now. Maybe always add a to-do of the file. First I want to get it to work, and so that is, how much do we have? Green, we have 5 bits, on the other 4. The green channels used to indicate general direction. The change encoded in 6 bits. Oops. Did I say 6? I think I said 5. The red and blue base their diffs of the green channel difference. Example difference red, difference green. What? The green channel difference from the previous pixel. The red channel difference minus the green channel difference. Minus. Okay, so the green channel difference the current channel values are using a wraparound operation, so 10 minus 3 will result in 253, while 250 plus 7 will result in 1. There is a stored unsigned integer with a bias of 32 for the green channel and the bias of 8. Okay, so we need to add 32, basically shifting that a little bit. Okay, the alpha always remains unchanged here. So the alpha channel differences you apparently can't encode in its difference. Welcome everyone. So, okay, so bias, what did I say? 32 minus 1, 8 and 7. Wait a second. Does it correctly? Wait a second. Maybe we need to be a little bit careful to get the negative sign right there. We need to sign extend that. How did the original code do that? They have here. What did we do? Okay, they do this quite similar. Oh, wait a second. Wait. Wait a second. They don't. I think they don't encode that 2 complement, huh? It's much here. One sheet of specification. How many are we approaching? 2 hours. I didn't even quite get that. That was a little bit unclear that this is not previous pixel minus 2. Do they say with a bias of 32 with a bias of 8? Somehow I didn't quite get that reading, that RGB. So yeah, shifting that like we do. RGB. So this was a difference operator. Minus 2 was that. This was here. Okay, minus 2. Okay, so this was also wrong already. We could check operator precedence. Okay, they shift this. Okay, they shift this first. Actually, yeah. Yeah, maybe that is slightly. So this was -2. This is indeed using the same mask. Maybe optimization was partially better. 4, 2. And so what I sometimes do just for readability, but in general I would want to try if we can use bit fields or so, if this is, but sometimes for documentation purpose and like making this stuff like, yeah, because here this looks a little bit asymmetric, shifting this by 0 and compiler surely optimizes it away. What was it? -2, right? -2, -2. So difference. Basically, let's do they probably, yeah, so they have the green difference. Well, they use an integer. It's a little bit wasteful. Not that it would matter so much, but you assigned 8. Difference green equals tag. What was it? The lower 4 bits. Lower 6 bits. And theoretically, in general, I need to find a good balance for that. I, in general, would want to have no magic values in that whatsoever. But first, let's get it to work, and then it's prettify a little bit more. So tag 0b and 6 bits, we said. We could check operator precedence, whether we need this, but wait a second, -32. Oops. Yeah, no, I pressed your sum. -32, yeah. So yeah, so this is not 2's complement. I wonder if it would be tiny little bit more efficient, but although with 2 complement you would need to sign extend that, so maybe not particularly more efficient machine code-wise. Anyway, so signed 8 z, maybe we call this diff g, difference g to make it a little bit more. I mean, either we call this dg and d, or leave in the comments below. So, so we need to subtract that. So this is signed 8. That probably should work. How many? So this were 4 bits, right? D difference minus dg, and that is biased by 8. So pixel g plus difference g. Also, I mean, theoretically the compiler should order this for the most efficient. RGB. Green, RGB, previous, current pixel, minus, so that is an encoding, so oh, US keyboard is killing me. And then the, wait a second, green is only that, plus the other difference here. So that is difference, and so red is first. So that before. Wait a second, this difference actually, yeah, this is unsigned, the whole thing. Need to be careful there, not to get the sign extended. And +8. Wait a second, -8. -8, did we? -2, -32. -8, and here. Oh, actually, this is funny. Yeah, theoretically, we could. I mean, we could end that unnecessarily, and have this here fully symmetric, or only end that here. I mean, theoretically, we probably would want in like a microkernel. Oh, hello. US keyboard. Darn. We certainly want some really pretty helpers for bit masks, shift sets, and stuff. So, and bit fields. That -8. Are we finally done yet? Again, something node matching control reaches. So we have again maybe here, or how do we constantly mess up our here, there? Okay, this is now a little bit. Wait, why is this only indented one? How much? Yeah, so this indentation like that is somehow, maybe I shouldn't. Maybe I should somehow configure Emacs so that it indents more useful. Okay, this is still completely 0. That is a little bit unexpected. How many channels are those even? Do we have some? We have here Wikipedia with 3 channels, for example. Let's also, I think this was huge. Let's 512, let's use Codem 10. Hey, that already decodes something. So that is only partially broken. Okay, it should look like that. Okay, this is actually, you know what, it's already partially visible. Surprisingly, I'm actually surprised that this is also the wrong. So what does not work? I'm surprised this. So probably some run length stuff, at least. So I'm surprised that this start of the sales or the start of the line already correct, and the start. So I mean, it's not entirely broken. So this now comes up, of course, yeah. Actually, debugging that's the more annoying thing. So there appears to be a bug either storing the history, but so maybe our index here. So maybe we store. So this is actually pretty complex to debug now. So either we store this wrong, or so you could now step through this with a reference decoder and compare the values. Actually, this does not look too bad. So those only, I think they are interesting that already decodes quite okay. So it looks like only some operation here we got wrong. Let's go meditate shortly. So this we break out here. So switch, break, default here. Maybe actually a little bit more spacing. Case break here, case break there, case break there. I mean, somewhat surprised that it works, but yeah, 20 years experience. It's like, except using the wrong keyword here, but can we make this somehow ident a little bit more nice? Okay, this is not nicer. Although maybe I shouldn't trust the Emacs default. Wait a second. This is also wrong. There is or case. So default. So we break out of all the cases, of all the switch cases. That is often a common mistake. Switch this, take switch that. Iterator. So we somehow drop out early anyways. So this is run links IT equals end. Is the end with this is also wrong. We need actually this is why we stop decoding early. So this is actually image. We could basically stride, I would say. Oh, wait a second, stride? No, stride. Yeah, I think it should be stride. We have a couple of small nuances there. Hey, and we get this probably correctly decoded. Okay, we can decode some, but some other we still mess up. So I think I think probably 90% of this code is working. Let's see. So this one looks identical, at least comparing this with the human eye. So this obviously not. So this should be relatively easy to debug. Zooming in there and checking, because it's probably one early pixel failing there already. Yeah, so we could probably relatively early find out which. I mean, so this is probably some kind of delta storing, because all the other. So this, for example, works. So others is test. Okay, this also fails completely. This is test card with RGBA. So looks nice, all right. So we are mostly there. What would be can we fix probably one last bug before we spend 2 hours on this? What would be, I mean, we could try to fprint debug this if we want to try a low-hanging, oops, oh, too many key bindings. If we, maybe some of those, so probably this index probably should work. And we could add start with Pullman's printf or C error. I would expect all of them. I could actually make this one once, not to spam the whole tag 420. It's maybe like the Lumars thing or so. RGB signed 8 DG of. Oh, wait a second. Oh no, DG plus. No, this probably should be right. It's just a question, is this overflow stuff working correctly? So Luma. Did we div Luma? Let's see. Luma div run index. What else do we have? Oh, here we have RGB. This probably should be fine, shouldn't it? Read pixels 3 or 4. Maybe we lock that too. I mean, very theoretically, we might want to specify this as packed because we read that straight to, I mean, not that it probably, but you never know. I mean, if you write like more sophisticated software, microkernel and stuff. Also, I would actually say, like in my dream language, I would not use it with this crazy attribute stuff. That syntax-wise, it's a little bit, yeah. So now we get this debug log output stuff. So the working one, so basically we could capture that already. D log sort unique. Oops. Okay, we use div index. Actually, what's this? Uses already all. This uses all and still div index Luma RGB. It's already using all and decoding correctly. That is unexpected. Did we have any other RGB index? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. 1, 2, 3, 4, 5. What we use all and that is interesting. Can we guess from this pattern already which? I mean, you know what we could actually do? Is disable storing some pixels and see which one are not stored, which compression or even that. I mean, yeah, so this guru meditation is now a little bit RGBA, see any maybe we should look at the reference code, and if we see, do they have alpha? No, they don't have. Where do they store the run? The index. Okay, they update this color index here already. It doesn't matter though for our case. RGB. RGBA. Okay, they have this a little bit funny. They have here the run lengths. So they have here. They also always have a run length. How does it work with the run length? Did we mess up the run length? The run length is 0. Otherwise, read the next operation. Where do they store? Here. Or, but wait, this looks. If run length, okay, the indentation here is a little bit funny-ish. Okay, they have a similar concept, except that I have the run length explicitly at the end here. That can that be? Hopefully not. This is funny. They don't optimize that. Also, I would assume that should store correctly. Do we mask that correctly? Where is their index? Okay, they directly index without masking that, because as I said, this is already the high bit's not set. I probably didn't observe. Where is the mask? I had that here. Let's for a test. 64 it was, right? And here the high bits are already not set, so index there, store, where do we? Okay, we could actually store it first, doesn't really matter too much, also maybe slightly better cache efficiency. We probably could even optimize that to only, yeah, probably doesn't matter too much not to store it in the indexed case. Okay, that didn't make a difference. Was this before also? Completely empty. This is extremely surprising, given especially that some images work. I would expect this to be some undefined overflow behavior or something of that sort. Where do we have? Maybe we check their code so and maybe we reading the stuff probably should be okay. Index, so this is a pixel from the history, RGB, so B42, do we have something mixed up there? So that is a div. So we have tech 4200 and then -2 RGB, that looks also correct. Luma. Why do they have here? Wait a second. Maybe this Luma -8 here? Do they have? Oh no, they have. Oh no, this is the same. We just have. They have -8 first, and we have it later. That is. Oh wait a sec. Yeah, -8. -32. Could this mask be 1, 2, 3, 4, 5, 6 bits? This is why, yeah, 3F in my opinion. The other one is more readable. Tech. So yeah, this, in my opinion, this is byte 1 and 2 and stuff. I think I would find this tech stuff more readable instead of B1 or. So they have here, because they have B1 -32. Could the signed 8 be something of trouble? I think this should underflow and stuff correctly. Or actually maybe this doesn't. Maybe this could potentially be if. Maybe if. Do we need to cast? If this is an int, the tag is an int, right? Or in the tag is, yeah, the tag is an int. Oh, wait a second. Oh no, int works. Int should be signed, shouldn't it? Ah yeah, that is -1. Okay, okay, this should work. Get the next D and oh, maybe this one here. Maybe should what do we do there? There's other differences. Maybe we try this assigned just to make sure that this over underflows correctly. So this is RGB plus there, DG. Why do they call this VG? V for value? I think I prefer D for delta then. And 0 maybe we need to be careful now that this is signed, not to. Now we have. Just to keep this fully symmetric for readability. DB2 shift 4 shift 0 and -8. That also didn't fix the same. Pity. What else could it be? It's nothing super obvious. Do you have any tips from the audience yourself? The usual stuff, right? 90%, yeah, 90% of the stuff takes 10% of the time or so, or vice versa. Signed D, so far nothing of this stuff fixed anything. We could, however, maybe we should start trying, because I think I commented it out. Was it okay or something? This one. Oops. Maybe from the pattern we could guess which. So I mean, we decode and set the right amount of pixels, as you can see. So even all those fine details here are there. If we probably could even. So this is for sure loading. Loading a full RGB value. So this is probably some small different thing not working as expected. So here, for example, here it even actually the second line is completely wrong. Where does it even start? So where we could debug that potentially is outputting which tag is used with XY coordinates and comparing this here with the viewer. Okay, so the first line looks completely correct, at least visually, and the second line here starts wrong. I mean, funny is that here the second one is it's for sure not this RGBA loading, but let's leave it in here anyway, especially for counting. And then okay, we don't have X and Y here though. We don't have even pixel. minus begin. Whatever, x equals I y I divided by, just try it, and I hate US keyboard layout. Yes. All right, very clever. Wait a second. Begin. What does that? Where's my log output? All right, okay, there's my log output. So that would be, oh, wait a second. So we have, okay, we have RGB. Okay, so this is because this is, okay, we have RGB run. Okay, 0, 1 is index. And then run, so which one is, this is also how this compresses by the way, right? So we have one VFA RGB and then some, what RGB, how is, we need multiple runs because this is a maximum of 64, also 64, 63 pixel. This is why we need multiple runs. So let's see, I think, okay, this should be gray and it isn't, so the first is index, so it looks like the indexing doesn't work. Or I would say, because it's index and then run, so 0, wait a second, how is this, 0, 1, 0, 1, yeah, this is just, okay, so I think the indexing doesn't apparently not work for some reason. Hello. So the indexing is index pixel equals history tag. How does that not work? Pixel equals that. Do we not store it correctly, or QOI index of pixel equals pixel? Is that potentially, where was this index? Somehow I pressed now something. Index. So index position. Could we have messed up anything in there? Oh, wait a second. How do they also assign? Why do they? Wait a second. Oh no, we. Okay. Why do they not have that color hash in? Okay, the color hash does not include the modulo for their stuff. Why? Index position. Index position. So they have this if it's. Wait, what do they do here? Oh, wait a second. This is probably compression. Encode, yeah. So RGBA, let's. RGBA, so R multiplied with 3, G multiplied with 5, G multiplied with Z. By the way, do we have the right? Oops. Does not look too bad, to be honest. I mean, we could QOI index from pixel. Maybe we log that. History from tech. And history. Oops, I think I pressed there some. History also. No, I just changed the type, so QOI index print will print some garbage. QOI index pixel. Let's make this. Yeah, so we already limit that to 6 bits. Let's make the 16 bits just for the printout, so the logging magically logs the right thing. So what this allows us only to change rule building. What do you use change rule building stuff 52? What exactly do you mean with that? Do you mean Do you mean that using a like change root jail poor man's container, or what exactly is the? Do you mean with that? So 16 we don't really know. Let's. Oh, wait a second. 16. Do we even use 16? We don't even use that. So maybe delete that. logging takes a while. So we history 13, okay, 13, 13, 13, 13. And then run. RGB. History null. Index 2. Okay, this is actually indexing an unused as far as I see. Oh, wait a second. History 0, history. So this is indeed indexing into an unused history. So something is wrong there. So this all this history is 13. That history is 0. Something is wrong there, I think. I mean, obviously it already looks wrong. Are there any hints running? Array 0 initialized pre-seen pixel values is maintained by the encoder and decoder. Each pixel that is seen by the encoder and decoder is put into this array at the position formed by a hash function of the color value in the encoder if the pixel value of the index matches the current, if the pixel value at the index in the encoder written to the stream as op index. Each chunk starts with, okay, we knew that, index, so what could possibly go wrong there? Where do I have here? Index. 00 index, 6 bits. Index into the color array index of 0 to 63 valid encoder must not issue 2 or more consecutive op index chunks to the same index. It's a little bit disappointing that everything works, but the most trivial QOI index. What could possibly go wrong there? Do we encode with alpha or not? Maybe do only non-alpha images not work? Oops. So this let's identify darn Q QOI. So we have 3, 3, 3, 4. Let's see. Maybe only the alpha channel. Maybe they expect something different with the alpha channel. QOI, QOI. So that is with alpha, that works. Codem, so this is not alpha, that doesn't work. That is not alpha, that doesn't work. Okay, this has alpha, that works. Okay, this alpha also doesn't work. Test card with alpha. Test. Oh, does it? Wait a second. RG. Test card Q. Why does it? Wait a second. Why does it? Test card QOI. Why does it not have alpha in the name? And Wikipedia, so this also doesn't. So mostly without alpha doesn't work. They said it should be 0 initialized. Do they say something slightly different? Color hash. So they always hash alpha as well, which of course will be 0. Index. So the alpha should usually remain 0. Okay, this is actually the encoder, decoder. Channels, 0 channels. What? Why is this relevant? What does it do here? Decode for channels? Yeah. Not sure what they do here. Here. That is probably the thing. Huh. So maybe our only bug is that they start with an alpha, and I wonder if this is written in the spec. So the history is 0 initialized, but the alpha value is fully opaque. I wonder if that is written in the specification, or if we, young and naive, overread that. So then that makes the pixel basically, do they, I think C++ does not yet support designated initializers, or do they? Maybe in C++ 20 whatever X. So yeah. Otherwise, if we could otherwise alpha equals dot alpha equals, but I think this will not compile, at least with most C++ compilers from the last decade anyway. Which is a little bit annoying that like they add so much random garbage and then the small stuff. Oh, that builds? Oh. Okay, let's see if that, hey, yay, only one small tiny little, yeah, so obviously all the hashing, so yeah, one tiny little bug that is, yeah, actually maybe we should read the freaking specification and see if that is a bug inside it. So this is only the decoder. Encoder hopefully wouldn't take the same amount of time because we have all the defines and stuff tested. So I would hope that takes less time. Hope always dies last. So we can change some stuff. So this is basically U8. Obviously all the printing stuff out there. And also the whole stuff here. Theoretically we could we certainly should optimize the heck out of it because our stream use is not the highest performance. And what else? We had this here tiny, we had that here as unsigned, and then we had we didn't end that. Wait a second. Yeah, so with unsigned, that is not sign extended. So basically, what do I even do here? The other way around, actually. We need to end that 1, 1, 1. And that. Not. That just shifts. That was, yes, it's not fully symmetric, but oops. Does that still work? So there is some history printout. So yeah, so far so good. 2 hours plus a little bit. Oh wow, a little bit, yeah, 2.5 hours. Yeah. I wonder, maybe we should quickly check. So yeah, there's a tiny little bit of error handling, end of file, and so on. I will commit this to the ExactImage repository if you're interested in this stuff. The specification was like here. Here, down where it starts with. Now here they write this. Okay, so it's in the specification. We just, yeah, one half line, and yeah, but only one half line, one tiny little thing. Maybe I later change this to not designated initializers, because if you wanted to build this with a 5-year-old C++ compiler, this would be 0.0.0.255. Yeah, this is of course only a small quick hack. Could need some more improvements. That looks so far so good. Should benchmark that though. Yeah, there you have it. Some development. Oh, sorry, epilepsy warning. That wasn't intentional. Sorry for that. Yeah, we should benchmark that another day, and we should implement an encoder. Encoder should be, yeah. We could also implement delayed loading so that identifying those files doesn't decode it all. So basically, some more error handling. Encoder delayed on demand. ExactImage supports this, otherwise with JPEG and some other file formats. On demand decoding. What else? And maybe proof of concept gray 8, because why not? So yeah, that's probably it. All right, theoretically maybe try bit fields. Oops. Maybe first try bit fields also for the something of that sort. I also should add some of those image files, like maybe at least 2 image files to the database, to the test suite. So yeah, there you have it. Just some open source fun. Yeah, leave in the comments below and what you think there was. If you made it so far, then you probably know already everything about the image format, but otherwise there was also the 10-minute or so more main channel. Otherwise, I hope you learned something, including C++ and image formatting stuff, RGB and other bits and pieces that make up digital images and file formats. I hope you learned something. Don't forget to like and subscribe, and I hope to see you soon for all the next fun stuff to come.